Good afternoon today, and how are you doing, everyone? Whatever time you are watching this video from, I wish you well, and I say may the good Lord protect you and guide you in your studies. This is Mr. John Jones. Good afternoon. Okay, today we are going to solve 2020 GCE paper, and definitely we'll look at the science paper 1. Science paper 1 is commonly known as physics. So this is the one we are going to deal with, and we'll only deal with question 7 and question 8. That's section B. So let's quickly start. This question is from the transformer topic, and the question is saying a step-up transformer increase the voltage AC supply. Just this, when you reach here, take note of the numbers. So I'll start collecting my data from this statement. They are saying in the primary core, sorry for the line. Okay, they are saying voltage of AC supply from 110. I'm reading here from 110 to 220. So meaning the voltage in the primary core, is 110 volts, and the voltage in the secondary core is 220 volts. That is according to the statement. Then we can go back to the question, and they're saying the primary core dissipates a power of 1.1 kilowatts, and the transformer has efficiency of this percent, 100%. If the number of turns in the secondary core is 400, how many? Okay, so they're asking us to find the number of turns in the secondary core. If in the primary core, the number of turns is 400. So they're saying the number of turns in the primary core is 400 turns. Then what is the number of turns in the secondary core, which is X? So from here, we'll say number of turns in the primary is equal to the voltage in the primary over the number of turns in the secondary, which is equal to the voltage in the secondary. Then we do the multiplication here. Voltage in the secondary. Then we do like this. All we want is to find this one. So we are going to have the number of turns in the secondary, which will be equal to the number of turns in the primary multiplied by the voltage in the secondary over the voltage in the primary here. Yeah, secondary, then primary here. Thank you. Okay, so this is the formula we are going to use. Then we replace the numbers as per given data, then we solve. So from here, we are now going to solve it this way. So data is here. We already been given the data that we collected. So just start replacing the figures there. So by replacing the voltage in the primary, voltage in the secondary, so we're going to say 220 volts times 400. Say 220 volts times 400 over 110. Then here we are going to get 8,800 or 88,000 divided by 110. So when we divide these, we are going to get 800 tons. So the number of tons in the primary core is 800 tons. Done. Then the next question, how much current is that? Okay, so here by using the formula of current, we would say the power in the primary is equal to the power in the secondary. So power in the secondary, we're saying the transformer dissipates 1.1, which is 1,100 watts. So now current in the primary we don't know, times the voltage in the primary, which we have been given to be 110. So in our calculations, we are going to calculate to say the current in the primary is equal to the power over the voltage in the primary. This power I'm using the 1,100 which has been dissipated. So the current in the primary is equal to the power is 1,100 watts over the primary. The voltage is 110 volts. So current is equal to 10 ampere. So our answer will be 10 here. 10. Am I writing in the correct space? Not here. Instead, it is here. 10 ampere, like that. Then the second one is secondary core. The current in the secondary core. Okay, so to find the current in the secondary coil, if we have the current in the primary coil to be 10, and then we'll multiply with the voltage in the primary coil times the voltage in the primary coil, which is 110. Okay, which is 110, which is equal to, and then the current in the secondary coil is the one we're finding. The voltage in the secondary coil, it was already 220 that we are given. So meaning we divide by 220 here, we divide by 220. So when we divide this and this will go, so current is equal to 1100 divided by 220. Therefore, the current in the secondary coil will give us 5 ampere. So meaning here it is 5 ampere. What is the next question? That's all. I think that's the end of question B. Okay, let's go to now the next one. Is this the end of the question, or we have another one? If there's another, you can still post. We can end there.